Hey, hello everyone. Let's review the last class first here. Okay. In the last class, we first saw the definition of data. Data is a collection of data objects and their attribute, and we also define the attribute and object in the data set. The attribute is a property or characteristic of an object. So any property of the object can be considered as an attribute. And the object is a member in the data set. So the object also called record, point, case, sample, entity, and instance. So this is the table of typical data set. Each row denotes the each record and each column is about the each attribute. So, and we saw the several types of the attributes values. Uh, we saw the nominal attribute, the ordinal attribute, the interval and ratio attributes, and we also saw which types of the operations can be applied to the which types of the attribute. So, for example, the distinctness can be applied or nominal, ordinal, interval, ratio for attributes. However, the order operation cannot be applied to the nominal attribute. And we saw the difference between the ratio and interval attributes, which the one of which has the absolute meaning of 0. However, the other only has the relative meaning compared to the numbers. And we saw several other classification methods for the attributes. For example, we can classify the attribute into the discrete attributes and continuous attributes. And some attributes can be called asymmetric attributes because most of the attribute values are zeros and only a non-zero attributes are important. For example, was in the documents or the items in the customer transactions. And some attributes are incomplete, asymmetric, cyclical, multivariate, partially ordered, and blah blah blah. So if you are curious for these types of attributes, please find it Google or any other search engine, then you can get the definitions of these types of attributes. So today we will start from this page. We first see the important characteristics of data. Here are here 4 characteristics of data are shown. These are actually major characteristics that define the properties of the data. The first one is dimensionality. Dimensionality of data is actually the number of attributes in the data. So if data has 10 attributes, then its dimensionality is 10. If it has 20 attributes, then its dimensionality is 20. So then, why this dimensionality is important? Because some data has very high dimensionality, and this high dimensional data sometimes brings a number of challenges. One of the famous ones are the called curves of dimensionality. The curse of dimensionality means that in a very high dimensional space, in other words, the space that the object with very high dimensionality lays, in that space, the most distances, for example, the Euclidean distances, lose its meaning. So many analysis methods based on the distance performs poor if the dimensionality of data is very high. In this chapter, in the end of this chapter or middle of this chapter, we will see the definition of distances, maybe in the next class. However, please remember this time, please remember that if the dimension is very high, then some analysis cannot be applied to that data, or the dimension should be reduced by some dimension reduction method. And the second property of the data is sparsity. Sparsity means, in Korean, 희소성. We usually call the data is sparse. Means that many entries are zeros. So if many entries of data are zeros and only a few entries have non-zero values, then we call this data is sparse. Or this object is sparse, means that that object has only a few non-zero elements. And we call the sparsity is high, or high sparsity, or highly sparse, means that many entries are just the same, actually the same. However, high means that more entries are zeros, and if the sparsity is low, it means that although it's sparse, however, there are some more non-zero elements in this data. Okay, so sparsity means that how much or how many elements are zeros in the dataset. And here the resolution. Resolution means that how precise your data attributes or your data attributes values. So if your data attributes has, for example, 6 digits after decimal point, then we can say that it has high resolution. However, you have only 2 or 1 or 2 digits after decimal, then sometimes we call this one as low resolution. And if the data has high or low resolution, sometimes we can find some different patterns from different resolution of data. For example, if we measure some, okay, for example, this is y value and this is x value. If we measure not x and y, okay, this is the data object, and this one is the attribute values. And if we measure with the high resolution, it means that we make some fine grain between the attribute values. So we may measure, for example, like this. So in this case, we can find the patterns. However, if we make low resolution, so we only measures, for example, like this. If this value is higher than 0 or not, then every value is higher than 0 here. So we cannot find the patterns that we found before. Okay, so the resolution of data can affect the patterns that we can find. And the size means the number of objects in the data. So the size of data can affect the availability of analysis method. Some method only can be applied to small number of data instances, or maybe some other method requires a large number of times if when it is applied to large size data or large scale data. Okay, it's actually beyond a little bit beyond our class. However, when we saw the time, we use this term, the time complexity, an algorithm. We usually notate it as big O notation, O for example, and square, or O and cubic. It's roughly saying that this means that here's the algorithm, and if this n is the number of data points, then roughly saying that if the number of data set becomes twice, then the time requirement for this method increases 4 times. Or if the algorithm is O and cubic and cube, then if the number of data becomes twice, then the time requirement increases 8 times. Okay. So you don't need to know this one for this lecture. However, we need to consider that some analysis may depend on the size of data, especially on computational time. And there are several types of data sets, of course. The most typical one is the record data set. The record data set is the data set forms with matrix. So data matrix or document data with the word presence or the transaction data can be recorded. So the record data is usually the records can be separated, one record. So for the document data, here's the one document, second document, here's the third document, and transaction, we can make the first transaction and second transaction, third transaction. They are the record data, and they can be considered, usually they can be considered independently. The graph data consists of the nodes and edges. For example, here are many nodes, and some nodes are connected to some other node with the edges here. These types of data are called graph data. So the typical example of the graph data is World Wide Web, or in this case, social networks. Your Facebook friendship can be considered as a graph data. And also here's the molecular structure. For example, for water, O, H, H. Okay. This is also can be considered as graph. So the molecular structure is in the point of the data analysis, it can be considered as a graph. And there are some other types of data set which is called ordered data set. So here are several examples for the ordered data set. Ordered data set means that each data has some relationships. For example, the spatial data. Spatial data is data are related in the space manner. For example, we have some information that this one is next to this one, or this one. Okay, how long the data points are, how far they are locating, or that kind of things. And temporal data are similar. However, they are related in time manner instead of the space manner. Okay. So this one is the data about the time, and some data are related to both space and time. Then we call these types of data as spatial temporal data. And sequential data are also similar, but they have the sequences. This one is given after this one is given after this one. They have some orders. We call this data as the sequential data. And genetic sequence data is the example of the sequential data. We know for example, the structure of DNA, there are A, T, C, G, blah, blah, they have these sequences. So this genetic sequence data is an example of all those data. So this is the example of the record data. Record data consists of the collection of records, and each of which consists of fixed set of attributes. For example, this one is one record, and this one is one record, this one is one record, and they have fixed set of attributes. Every record has the refund attribute, marital status attribute, and taxable income attribute, and default attribute, of course. And data matrix is actually very similar with record data. However, here, if a data object have the same fixed set of numeric attributes here, the difference between this page and this page is that here it has only numeric attributes, or some other attributes that can be transformed into numeric attributes. Then the data object can be thought of as a point in a multidimensional space, where each dimension represents a distinct attribute. So here, for example, this one is one record and this one is one record, and they have, all of them have fixed attributes, and these attributes have numeric values. So each record can be considered as a point in 5-dimensional space. Okay. For example, 10.23, comma, 5.27, comma, 15.22, comma, 2.7, comma, 1.2. Okay, this one is the record one, and it is a point. It is actually one point in the 5-dimensional space. So in this case, the data can be represented as n by n matrix, where there are m rows, one for each object, and n columns, one for each attribute. In this textbook, here are m rows and n attributes, so it means that it has m records and n attributes. However, in user machine learning textbook, they are exchanged. So they usually n recurs for data points instances and m attributes. And they have n by m matrix. However, in this textbook, they denote record as m and they denote attribute as n. However, however, the system with n record and m attributes are more common. And this is document data. Actually, this document data can be represented as a matrix. We usually call this one as term document matrix. Term document matrix. So in this case, each document becomes a record, and each term is a attribute of this record. So, okay, let's first see the definition first. Okay, here the attribute values means how many times this term presented in this document. So here it means that the word team is presented 3 times in document 1, and word coach does not appear in document 1. Word play appears 5 times in document 1. Okay. So these are the attribute values. Is actually frequency of the term appears. So this data, we can easily expect that this data matrix is high dimensional because these attributes should consist all words that appear at least once in the documents. Okay, so these term document matrix are usually very high dimensional, and usually it's sparse because there are many zero values in the attribute values. So this is usually high dimensional and sparse. And transaction data, we are not usually handling transaction data, but okay, let's see the definition of the transaction data here. The transaction data is a special type of data where each transaction involves a set of items. So each transaction becomes the record, and it has the set of items. It's actually a set. A set means that set has the elements, and the order of elements are not important. Okay, so here the transaction ID 2 has items beer and bread, and actually this is a set, so that beer and bread is actually the same with the bread and beer. So the order of items in the transactions are not important. And the there are actually, in theory, there are no limitations for the number of items. So some transaction has only one or two items. However, some other can be 4, 5, or many more items in their transactions. So the typical example of this transaction data is a grocery store. The set of products purchased by a customer during one shopping trip constitutes a transaction, while the individual products were purchased are items. Okay, so for example, the one customer bought bread, coke, and milk, and the second customer bought beer and bread. The third bought beer, coke, diaper, and milk. So these are the typical example of transaction data, and this transaction data is also considered as one of the record data because it records. And with this transaction data, we usually conduct the association analysis. It means that in this analysis, we found the rules of the most frequent transaction. For example, hmm, if if a customer bought diaper, then this customer also bought milk with, for example, 100% support, and therefore to the beer 66.7% support. The association analysis found these kind of rules from this transaction data. We will not cover this association analysis in this semester. However, if you are interested in this analysis, please refer to this term, association analysis. And these are the examples of the graph data. Graph data has nodes and edges, and the example of graph data is the chemical molecules. And this one is the hyperlinks worldwide. In the World Wide Web, this one is hyperlinks. And these edges can be both directed or undirected. So the edges between the atoms in the molecules are undirected. However, the hyperlinks between the web pages can be directed. There are only one way, and it does not guarantee the other way's existence. And this is the example of the ordered data. Sometimes the items or events have some sequences like this. First, second, third, first, second, third, first, second, third. Then these types of data is called sequence data, and the genomic sequence data has the order. It has the sequence, for example, it has the order in this direction. So this data is usually considered as ordered data. And this is the example of spatial temporal data. This data this is the average monthly temperature of land and ocean. We can each figure in each figure is spatial data because these temperatures locate and has a relationship in the space manner. However, if we select one point and the value at this point is changing and changing, and this data can be considered as temporal data because the value is related in timely manner. And in total, the figures changing in this manner is called spatial temporal data because it has both relationship both in space and time manners. Okay, this is the end of the data properties, and the next topic is data quality. Data quality is very important in these days because many models or many process are relying on the data. So if data qualities are bad, then the performances of the data analysis models are also poor, even though we use many data processing. So poor data quality negatively affects many data processing effort. So the data quality is the first step of the good analysis on data. So here, for example, a classification model for detecting people who are low risks is built using poor data. Then if the data quality is poor, then this model is made with very poor performance. So some creditworthy candidate can be denied loans, or more loans are given to the individuals that may default or with high default risk. So if the data quality is poor, this kind of system cannot work in an appropriate manner. So there are many open questions for the data quality. So here first we need to know what kinds of data quality problems and how can we detect the problems with data and what can we do about these problems. The answer for the first one is here. What kind of data quality problems? There are so many types of the data quality problems, but the typical ones are here. So first one is the noise, and outliers. And the second one is wrong data. The third one is fake data, and the fourth one is missing values, and the fifth ones are duplicate data. So here, the noise are usually the most typical factor that affects the data quality that you can find. So the noise is an extraneous object. For the in the object point of view. However, in most common for the attributes, the noise refers to the modification of original values. For example, in this figure, here the first figure shows the two sine waves, the black one and red one. If we take the sum of these two sine waves, then it becomes this one. It's actually the clean data, the sum of two sine waves. However, if we have noise, then we cannot get this clean data, but we can get the third one, the noisy data. So however, in the real world application, every data has noise because of several reasons. The major reason is the measurement error. So we usually get the noisy data. So the if the noise is very high, okay, in this case, noise is not that high, so we can expect the more analysis as similar to the clean one even with the noise one. However, let's assume that the noise is very high so that it becomes like this. Noise is high. Then we cannot get some similar result with these highly noisy data as the clean one. Maybe in this one we may find a signal like this, and it's very different from the clean one. So the level of noise or the ratio between the original signal, and noise is important. Signal noise ratio. Or sometimes we know the noise actually. Sometimes when we talk with our friend with the phone, then we have some distortion of a person's voice when talking on for a phone. Or sometimes we saw the snows. Snows means that the pixels with white color. Or sometimes we also have the pepper noise, the pixels with the black color on TV screen. Then these are usually considered as the noise. And the outlier, the next topic related to the data quality is outliers. The outliers are the data objects with characteristics that are considerably different than most of the other data objects. Okay, for example, let's assume that each point refers to the data object, and then we can find some data points that are far from the clusters of the data or group of data. These data points are called outliers. The outliers usually have two meanings in the data analysis. The first one is that they are, okay, here case one. The first one is that they are just noise that interferes with the data analysis. They just hinders our analysis. So in this case, we'd better remove these outliers if we found that some points are outliers. However, sometimes these outliers are important. For example, credit card fraud. Usually the status of the credit cards are normal and every transactions of credit cards are the normal transactions. However, if when we analyze the credit card transaction data and we found some outlying transaction, then it can be a signal for the credit card fraud. Or sometimes we can detect the intrusion, for example, in the network with the outliers, or some machinery faults. Machinery faults can be also presented as an outlier. So in this case, outliers are important and the points that we need to focus on, not the just noise. So in this case, we should not remove the outliers for our analysis. Here are the causes of outliers, maybe data entry errors, measurement errors, experimental errors. Intentionally, there some people made errors, errors in data processing, sampling, or naturally there are outliers, for example. Or if we collect the heights of the persons, then we there exists actually a person whose height is more than 220 centimeters. This is outliers, but it can be naturally exist. Okay? So there are also outliers from the natural uh, distributions in the real world. And the third topic of the related to the data quality is the missing values. Missing values means that there are some values of which some attributes which do not have values, or some attributes values are missing. For example, here's the okay. 1, record 2, record 3, and attribute 1, attribute 2, and attribute 3. Here's the 1, 0, 3, 2, 1, 0, and okay, it has 2. In this case, these kind of some attribute values are missing. We call this problem as missing value problem. So the reason for this missing value is that sometimes information is not collected because people decline to give their age or weight or other sensitive information, or it can be um, missing in unintentional manner. For example, just the the measurement machine is not working at that time, or some people who record this data forgot to record this value, or there are many reasons for the missing values. And sometimes some attributes may not applicable to all cases. For example, the annual income cannot be applied to the children's. So these missing values are usually deteriorate or blocks for many analysis methods. So we need to handle these missing values. So the first one is that the most naive and easy one is to just delete this record which has missing values, or deleting these attributes. However, if the record has missing values or attribute has missing values are very small, for example, only 1 out of 100 records has missing values, so we can easily delete that record. However, if missing rate means that the ratio of missing values compared to the all attribute values is more than 10% or 20%, then eliminating these records are very difficult. So in this case, we usually replace these missing values with other values. This process is called missing value imputation. So we put some values here. For example, we can put the average values, for example, of other values with the same attribute, which is 0.5 in this example. Or we can find the most similar record with R3. R2 is similar with R3 comparing the other attribute values. Then we put the 1 because we consider that this R3 may be similar with R2. So there are many missing value imputation methods. And some analysis method allows the existence of missing values so that we can ignore the missing values during the analysis with some method, only with some method. Some other methods do not allow the missing values during the analysis. So in this case, we must handle the missing values before the analysis method is applied. And the last topic related to the data quality is the duplicate data. The duplicate data means that, okay, here's some data matrix and there are many records of data. However, some data objects are duplicated. It means that the one record is recorded twice or more than twice. The major source of this duplication is when merging data from heterogeneous sources. Okay. Okay, for example, I have two classes, for example, and for the class A, there are many students A, B, C, D, and here are students. Oops. For the class B, we have students A, B, E, F. Then if we merge the students of the two classes, then A, B, C, D, A, B, E, F. Then here the student A and student B are duplicating in this case. So in this case, for good analysis, we need to find which data are duplicated and eliminating the duplicated ones. Okay. For more complicated, more sophisticated case, if we collect the email addresses, however, one person can have multiple email addresses, so the same email can be sent to one person in several times. If she or he has several email addresses and all of these email addresses received this email. So the process of dealing with this duplicated data issue is called data cleaning. So in the data cleaning, we need to remove all the duplicated data points. However, sometimes these duplicated data should not be removed if these duplications have some meaning. Okay. If some cases, if in some cases, these duplicated data may have the meaning of duplication. I cannot easily think of the example for the meaning of this duplication of data. Anyway, sometimes if the data, this duplication has the meaning, sometimes it is important that A becomes twice and B becomes also twice in this data set, then it should not be removed. Okay. So that is the case that when the duplicate data should not be removed. Okay. And this is the all for the data quality topics. And we need to keep in mind that the data quality is really important before we apply the data analysis method. So in this class, in this semester, we will not study the specific data analysis method, for example, deep learning or support vector machines. However, we will study, in some point of view, more important things for the data. We need to the way how we can find the properties of the data set and what we should do before we apply a sophisticated data analysis method to the data. Okay. The next topic is the similarity and dissimilarity measures of data. However, we have a lot of things for this topic. For example, dissimilarity and distances, Euclidean distances, and blah blah. So let's wrap up today's class here and see you on the next lecture. Bye.